We continue review exercise 2 with question number 5. In this question, we again use the laws of exponent to simplify this question. In the first part, we apply law of quotient power with same base. So q power will take into the numerator, a raised to power p minus q. It becomes p plus q whole power. A raised to power q minus r according to law of quotient power with same base, q plus r, whole divided by 5. We apply law of sum of powers as these values are in a product form. So bases are same, the powers are added, a raised to power p plus r whole power p minus r. This a is not equal to 0 is actually given for this sake. If we put the value of a equal to 0, that whole expression will become undefined. So therefore, we do not put 0 in place to find value of this expression in any case. Let's move to the next step, in which we observe that the values are in the form of power. So we apply the law of power. A raised to power p minus q. Power is multiplied to the power p plus q. A raised to power q minus r multiplied q plus r. We take the reciprocal of the division, which is multiplication. So we write in reciprocal form 1/5 into a raised to power p plus r into p minus r. We apply law of power. We apply formula on these parts, and that formula is a plus b into a minus b is equal to a square minus b square. Using this formula, what we get? We get a raised to power p square minus q square, a raised to power q square minus r square, multiply 1/5 a raised to power p square minus r square. As these three bases are same, so we apply law of sum of power as well as law of quotient power with same base at the same time. So we get a raised to power p square minus q square plus q square minus r square. We apply law of sum of power on this part, minus p square minus will become plus r square according to law of quotient power with same base. Actually, we add these two values according to law of sum of powers. We change the signs of these values according to law of quotient power with same base. Multiply 1/5 is left in that part. Like terms having different signs are cancelled. P square cancelled with p square, q square is cancelled with q square, r square is cancelled with r square. So hence we left 0 in power. So we have a raised to power 0 multiply 1/5. According to law of quotient power with same base, we know that a raised to power 0 is equal to 1. So therefore we can write 1 multiply 1/5, and hence that is equal to 1/5 is the simplified form of this question number 5. Let's do the question number 6 of review exercise 2. In this question, we apply law of quotient power with same base, as the same bases are present in a fraction. So a raised to power 2l. The powers in denominator move to numerator. The sign will change. L will become minus l and plus m will become minus m. A raised to power 2m. Again we apply the same law of quotient power with same base. Power m will become minus m and power n will become minus n. In the next part, the same law is applied. A raised to power 2n minus n, and L become minus L according to law of quotient power the same. 2L minus L will be equal to L minus M. A raised to power 2m minus m will become m minus n. A raised to power 2n minus n become n minus L. In the next step, we apply law of sum of power. As bases are same in a product form, the powers are added. So a raised to power L minus m plus m minus n plus n minus L. Like terms having different signs are cancelled. L is cancelled to L, m is cancelled to n is cancelled to n. We get a raised to power 0, and as we know that according to law of quotient of power, the same base a raised to power 0 is equal to 1. So therefore we have 1, and that is the simplified form of question number 6. Let's do question number 7, the last question of this review, exercise 2. In this question we have different ways to solve it. We use a different technique in which we apply the property of the cube root, and that is we take common third root a raised to power L over a raised to power m, multiply a raised to power m over a raised to power n, multiply a raised to power n over a raised to power L. In the next step, we apply law of quotient of power with same base, and according to it, we have a raised to power L, m becomes minus a raised to power m minus n, and a raised to power n minus L. By applying law of quotient of power with same base, we have. As these values are now in the form of a product, so we apply law of sum of powers. A raised to power L minus m plus m minus n plus n minus L, third root. Like terms having different signs, L is cancelled by L, m is cancelled by m, n is cancelled by n. We have third root of a raised to power 0. We convert that radical form into exponential form, a raised to power 0 whole power 1 by 3. In the next step, we apply law of power of power, and we have what? A raised to power 0 multiply 1 over 3, and what we get? A raised to power 0. On multiplying 0, every number will become 0, so we have a raised to power 0. And as we know that according to law of quotient of power with same base, a raised to power 0 is equal to 1. We have 1, and that is the simplified form of question number 7 of review exercise 2. I hope you understand the concepts related to real and complex numbers. You learn how to apply the laws of exponent. You learn how to convert the radical form into exponential and exponential form into radical form. You learn the properties of real number. You learn how to apply these properties and properties of root as well. So I hope you learn many things in this chapters, and that will help you a lot in mathematics in future.